Professor Bialis here. In this video, we are going to be talking about section 8.4, which covers variation. Now, these are going to be word problems. However, they're going to be a little different than the past. They're going to be very short, and they're going to be very structured. There's going to be a very specific formula and translation that we're going to be applying to every single one of these. Okay, so we're going to start with introducing the idea of variation and then go through a bunch of examples. So let's get going. First thing we're going to talk about is direct variation. Okay, direct variation. First of all, any kind of variation is just when you have two or more things that relate to one another, okay, that are connected in some way. So direct variation is when you have two things, two quantities, two values that are going to be related so that as one increases, the other will also increase. As one decreases, the other will decrease. Okay, so let's say the amount you study, your grade theoretically should also increase. Okay, the less you study, the lower your grade is theoretically going to be. So again, direct variation, just in general, is as one goes up, the other goes up. As one goes down, the other goes down. Okay, that's a general idea behind a direct variation. Okay, now the problems that they're going to be giving us, they are going to be naming two different things, sometimes variables, sometimes actual things, and they are going to tell us some values to show how they are related. So the problems are going to read something like this. They would say, for instance, y varies directly as x. Another way they could say that is y is directly proportional to x. Okay, those are two different ways of saying the exact same thing. Again, y is directly proportional to x, or y varies directly as x. Typically, it's going to be written like this, okay? And notice, in both cases, they talk about directly, okay? So that's a word that we really need to be able to notice, okay? Now, if they give you a problem like this, or a statement like this, we need to be able to translate that. Okay, once we translate it, the algebra of this is extremely easy. We just need to know how to carry out that translation. So let's see how that works. So y is y. Okay, but when they say varies, what they're telling you is that you are going to have to equal some constant k. That k is your constant of variation. Okay, what that means is that is going to be a number that tells you how closely they are related. We know if it's a direct variation, as one goes up, the other goes up. But as one doubles, is the other going to double? As one triples, maybe this, quadruples, and so on. So that's what that k is going to tell us. So y varies directly. Directly simply means we are multiplying, and then x is x. Okay? That's all the translation comes down to. So whether it varies or you're proportional to, you're going to have equal k. That constant k has to be there. Directly means you multiply, and then x is x. Nothing more to it than that. Okay? So let's look at a few examples of this. I am looking on page 543. This is practice 1. And it reads, suppose that y varies directly as x. If y is 20 when x is 15, find the constant of variation and the direct variation equation. Okay, so again, What we want to do is read through it once, maybe twice, just to get an idea of what type of problem this is. We saw those words varies directly, okay? Now that first sentence is what's telling you the formula that we need to use. Y varies directly as x. Y varies directly as x. Watch how I translate that. Y varies directly as x. That's it. There's my equation. There's my formula that I'm going to be using. Okay. Now it then says y is 20 when x is 15. So that's one measured collection of values. Find the constant and the direct variation equation. So find the constant of variation and the equation. Okay. So we have this formula, and then they tell us that we know that y is 20 when x is 15. Okay? I then can solve for that constant. K equals 4 over 3. Okay? There's my constant of variation. Now they also say what's the variation equation? The variation equation has to be a workable equation. This is our general layout, but it's not a workable equation. Just like when you have a slope-intercept form of a line, you have y equals mx plus b. For that to be a specific equation, you have to have a number in for m. You have to have a number in for b. We have to plug in that k. So this is our constant, and our equation is that. Okay? So all that tells you is find the constant and then plug that thing into the equation. Okay? So this is a direct variation. Let's now go on to practice 2. Now practice 2, if you're reading in the book, actually combines some information from example 2. I'm just going to read that example 2 information along with it. Okay, so it's going to state, Hooke's law states that the distance a spring stretches is directly proportional to the weight attached to the spring. If a 36-pound weight attached to a spring stretches the spring 9 inches, find the distance that a 75-pound weight attached to the spring stretches the spring. Again, if you're reading in the book, I kind of combined the beginning of example 3 with the problem in practice 3. Okay, so the first part of this found in example 2. I'm sorry, not example 3. So in example 2, it started out, Hooke's law states that the distance a spring stretches is directly proportional to the weight attached to the spring. So again, how would I translate that? It said the distance that it stretches is proportional, directly proportional, to the weight attached to the spring. So you have a spring and you're attaching a weight and it's stretching it down. It makes sense that if that weight is heavier, the spring stretches more. So as the weight goes up, the stretch goes up. So that is from example 2. Practice 2 says that if a 36-pound weight attached to a spring stretches the spring 9 inches. So we know that 9 inches of distance was stretched when the weight was 36 pounds. Okay? Now it then says, if we know that, find the distance that a 75-pound weight would stretch the spring. So, given this right here, we are going to find that constant of variation. If you've taken physics before, that's known as the spring constant. That gives you a number that you assign to a spring to tell you how strong that spring is. What I'm going to do is I'm going to divide by 36. And I get 1/4 equals K. Now, did they ask you specifically find that constant of variation? No. But we need to have that in order to find anything else about this spring. And in particular, they want to know, if I attach 75 pounds to this thing, how far is it going to stretch? Okay, so let's find that out. I got my constant. What about my equation? My equation should be distance equals 1/4 times the weight. Okay. What's good about this is, again, I have 36 pounds of weight, I can throw it on there. Well, I need this to hold 75 pounds later on, but I don't have 75 pounds. How can I test it? I can test it algebraically, okay? So what I'm going to do is find that distance when I attach 75 pounds to that, okay? And then when you work that out, what you should get is 18.75 or 18 3/4 if you'd like inches. Okay? Something like this. Let's say you were going bungee jumping. It's not really a spring, it's more of an elastic cord, but same idea is going to exist there. Let's say I know that cord has a spring constant of 1/4 or 2/3 or whatever it may be, and the person that I'm attaching it to, it weighs, 150 pounds or 230 pounds. How much stretch is that cord going to have? That'll determine how much cord you let out when that person jumps, okay? So, again, this first one was just very general. You got y and x. They want the constant, they want the equation. This next one is more of a scientific application, and we're still going to get the constant and the equation, but they're not going to specifically ask for it, okay? We need to know that those are important pieces that we use in order to find the information they're really asking for, okay? So let's now, again, that was practice 2. Let's now go into a different type of variation. Okay, what we're going to do is now go into what's called inverse variation. Okay, now inverse variation works differently. As one goes up, the other should be going down. The inverse direction of what the original is doing. As one goes down, the other should be going up. The amount of hours you play video games, your grade, in this class or any class typically. Okay, so as that hours of video game playing goes up, maybe your grades are going to go down. Okay, it's something like that, and that's a very kind of silly example, but that kind of gets the same idea of what an inverse variation would be. Whenever there's a correlation or some kind of connecting factor between two quantities, as they relate to one another, as they're both going in the same direction or they go inversely, we have this to describe it. Okay, now how is the phrasing going to work out? So it could say y is inversely proportional to x, or it could say y varies inversely as x. Okay, now the translation is going to be different. We're still going to have that constant of variation. However, this is what we're going to do to translate. We start with y. Varies is still going to be that constant of variation. Okay, so we're still going to have this being translated from that idea of varies. Inversely. What is inversely going to translate into? That's where we will divide. Okay, so when I say inversely, I mean divide. Directly, we multiplied. Inversely, we divide. Simple as that. And then as x, I carry the x down. Nothing more to it than that. Okay, we just need to know. Direct variation, you multiply. Inverse variation, you divide. The reason why we're dividing, as one goes up, the other goes down. If I, let's say, have a bigger number in a denominator, what happens to the overall value? Okay, that output value, that outcome value, if this goes up, the outcome becomes smaller. Let me show you. If I have 1/10 or 1,000th, okay, as this goes up, the overall value went down. Okay, that's why we're dividing in this inverse variation. So let's look at some examples of this. You're going to see that the examples are very, very similar to the first two that we have with direct variation. So let's start with practice 3. Practice 3 states, that's found on page 545. Suppose that B varies inversely as A. If B is 5 when A is 9, find the constant of variation and the inverse variation equation. Okay, so again, we're going to start by writing down our formula. We need to know how all these things interact. So that's the first sentence. It says again, suppose that B varies inversely as A. B varies inversely as A. B varies inversely as A. That's it. Nothing more than that. Okay, now we read on. B is 5 when A is 9. That gives us a complete scenario. B is 5 when A is 9. Okay, then it says find the constant of variation and then find the variation equation. So we're left with an equation that only has K as an unknown. Let's solve for it. I'm going to multiply by 9 and I get K equals 45. There's my constant of variation, and if I want the workable, usable equation, I have B equals 45 over A. And there we go. Okay? Honestly, whether they ask you for it or not, if they give you a complete scenario like this, find that constant, find that variation equation. Because even if they want you to use that, you need to find it in the first place. Let's go on to practice 4. Practice 4, again, is going to be kind of a combination of practice 4 and example 4. So if you're following in the book, I'm going to read it a little differently. It says, Boyle's law says that if the temperature stays the same, the pressure P of a gas is inversely proportional to the volume V. If P equals 350 kilopascals and V equals 2.8 cubic meters, find the pressure when the volume decreases to 1.5 cubic meters. Okay, now again, you're going to have to read through that a few times. That first sentence, though, is typically going to set the stage. Okay, so let me read that again. It says, Boyle's law says that if the temperature stays the same, the pressure P, so P, is inversely proportional to the volume V. So if temperature stays the same, so forget the temperature. Okay, we're kind of taking that out of the equation, literally. It says P is inversely proportional to V. Do you see how I took out all the extra wordiness in there? P is inversely proportional to V. So P is inversely proportional to V. Okay, so as that volume increases, as you have more space, the pressure is going to go down. So volume increases, pressure down. If I squeeze that and the volume goes down, then that pressure is going to increase because we're squeezing it all together. Now, I'm going to go back to practice 4 now, and it says if P is 350, okay, when V is 2.8, find the pressure when the volume decreases to 1.5. Okay, so for something like this, I just find that K value. By finding the K value, I then see how these two values are actually related. And then I can find any combination of numbers I want. So I'm going to multiply by 2.8. And then 350 times 2.8 is 980. So I get 980 equals K. That connects everything. Now, I need something I can work with. And that's going to give me P equals 980 over V. Okay? Now, the actual question has us use that formula. And it says that find the pressure when the volume decreases to 1.5. So now find the pressure when the volume is 1.5. Okay? Now, all you do is calculate that, 980 divided by 1.5, and we get 653. Now, you should be getting a 0.3 repeating. Don't put 0.3, okay, because that's rounding, unless they tell you specifically to do that. If you put 0.3 with the bar over it, that's fine, or you could just write a 1/3. Okay? And that is it. Okay? Now, double check. Make sure that everything makes sense. This was an inversely proportional problem. So, I had a volume of 2.8. The volume then went down. If the volume goes down, what do we expect about the pressure? Volume down, pressure should go up. It was at 350, now it's 653. That doesn't guarantee I'm right. I still could have made a calculation mistake, but that'll show me that I'm on the right track. So always look to make sure that your answers make sense. And if they don't, dig in and fix it. Maybe you multiplied instead of divided. Or maybe it's a silly calculation mistake, but know that something is wrong and we need to fix it. Okay? Let's move on. Next thing they talk about is a joint variation. Okay? Let me read this description for you. This is on page 546. It says, if the ratio of a variable y to the product of two or more variables is constant, then y varies jointly as or is jointly proportional to the other variables. If y equals kxz, then the number k is the constant of variation and the constant of proportionality. What I want you to get out of this, when you have a jointly proportional problem, when they say varies jointly, so it's not varies directly or varies inversely, varies jointly, all you're doing is multiplying again, but with multiple pieces. Okay, so when it's a joint variation, it's pretty much the same thing as a direct variation. Joint variation, multiply. Okay, let's look at an example. Let's go to practice 5. So practice 5 says, I'm on page 546. It says the area of a regular polygon varies jointly as its apothem and its perimeter. Express the area in terms of the apothem A and the perimeter P. Okay, so again, start off right away with the description of how these relate. It says the area the area of a regular polygon varies jointly as its apothem and its perimeter. Area varies jointly as apothem and perimeter. So area, I'm going to use a big A for area, varies now jointly. Again, jointly just means you're multiplying. I'm multiplying by that apothem A and perimeter P. That's it. Notice they didn't give you any values, well, if the apothem is this, and they just said, write that relationship. Nothing more to it than that. We're done. Okay, and again, just real quick, area varies jointly as the apothem and the perimeter. So we just keep multiplying. Nothing more than that. Okay, so let's look at another one. Let's go to practice 6. Practice 6 says, suppose that y varies inversely as the cube of x. If y is 1/2 when x is 2, find the constant of variation and the variation equation. Okay, so again, first sentence is going to tell you all you need. Suppose that y varies inversely as the cube of x. So watch me here. Y varies inversely as the cube of x. Okay? Then they give you some values. Y is 1/2 when x is 2. Find the constant of variation and the variation equation. So y is 1/2 when x is 2. So we have a measured scenario. We know that y is 1/2 when x is 2. Okay? Now, right away, I see a lot of people make this mistake. Notice, what am I missing? I forgot the cube. I have it up here. I need to calculate with that. So I need to cube that 2 as well. Okay, and then from there, I can go ahead and solve for k. So 2 cubed is 8. So I have a 1/2 equals k over 8. And then I can multiply by 8 to get k equals 4. That's my constant of variation, and my workable, usable variation equation is that. And there we go. Okay? So let's look at one more. Let's look at practice 7. So practice 7 says, I'm on page 548. Practice 7 says, suppose that y varies directly as z and inversely as the cube of x. If y is 15 when z is 5 and x equals 3, find the constant of variation and the variation equation. So again, first thing I need to do is get that general formula. First sentence says, suppose that y varies directly as z and inversely as the cube of x. Now, what they're doing is not a joint variation, they're combining different types of variation. But since we're multiplying and dividing, we can interact those different variations. So it says, suppose that y varies directly as z and inversely as a cube of x. Watch me here. Y varies directly as z and inversely as the cube of x. Y varies directly as z and then inversely as the cube of x. That's it. Okay? Now, let's dig in and get those values. It says if y is 15 when z is 5 and x is 3. Don't forget to cube that. Find the constant of variation and that variation equation. Okay? Let's see what happens. We've got 3 cubed is 27. I'm going to multiply by 27 because 3 cubed, that would cancel that out. Okay? Now, let me show you a little trick here. If you want, you could just multiply 27 times 15. Or, I know that I have that 5 coming. Let's divide by 5. Now, why would I do that? Let's say I don't have a calculator. Let's say my calculator broke. Let's say I don't want to have to deal with 27 times 15. Because now, I don't have to do 27 times 15. I just have to do 27 times 3. And what that gives me is 81. Okay? Again, if you don't like doing that and leaving those calculations undone, then don't do it. But if you're forced to do this in your head, mental math sometimes requires a lot of tricks to get good and efficient with it. That's one of those tricks. Okay? So we've got a k of 81. Therefore, our equation is that, and our constant was 81. And that's all there is to it. Okay? So variations. Direct variation, we multiply. Inverse variation, we divided. Joint variation is we multiply, but just by multiple things. And then sometimes they will combine different variations at one time. And that's perfectly fine. Just remember, direct is multiply, inverse is divide. Okay? So pay very close attention at the very beginning of a problem, because typically that's where they set the stage and give you this formula. Okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.